As an architect, I have had conversations with my development team on what database to choose. Should it be relational or should it be non-relational? And the answer is it depends. So for instance, in case if you see on the right, this guy wants to slice and dice then drill the data. So in that case, a relational database would be the right choice. So this is a summary of what is included in each of these categories. In the relational database, typically you have a lot of tables and there are joins between them. And obviously there are primary and foreign keys involved. Whereas in a non-relational database, it is collections or key value pairs. Now collections could be something like a MongoDB. Key value pairs could be something like a DynamoDB. In relational database, it has got a strict ACID compliance. ACID is atomicity, consistency, isolation, and durability. Whereas in a non-relational database, this is not highly enforced. Now, what is ACID in just in a summary? Atomicity means that a transaction either completes or it doesn't. It gets rolled back. Consistency means that the schema behind the scenes is stays consistent. Isolation means that if there are two transactions, like say two people are transferring money, then their transactions shouldn't impact each other. Whereas durability means whatever changes have happened leave behind their mark. So it's not as if you shut down the system and then the transactions suddenly disappear. So that is about the asset properties. Now, fixed schema in a relational means you have got say three columns. Then, if you have to add a fourth column, then your structure has to be changed. Whereas in a non-relational database, the schema is sort of flexible because each row can have different attributes. So, for example, a clothing may have an attribute of a size, whereas if the product is let's say tea, it may have got a flavor as a column name. Now, relational databases typically support vertical scaling and non-relational do support horizontal scaling. Now, vertical scaling means adding more CPU power or adding more typically, but in a relational database you add more IOPS because you will should be able to do more write operations and some other way by which Amazon RDS supports vertical scaling is having multiple read replicas. In that case, your read is driven through multiple nodes, but typically having multiple writes is a little restricted. Though in Amazon RDS, Aurora, typically not in RDS, but in Aurora, you have got capability to have global databases also, wherein you can have vertical scaling. Uh, then when it comes to the language preferably that is used, it is SQL for relational, and in case of non-relational it is more of API oriented because these are all JSON documents or XML documents, etc. In a relational, again, it is suitable for both OLTP as well as OLAP, online analytical processing, whereas non-relational is not well suited for OLAP because you have got different structures, etc. So slicing and dicing is typically not simple. Now, coming to the perfect database, is there something really like a perfect database? There is nothing perfect in this world, obviously. So, if you have to define what is a perfect database, then it has to support all different data types. It has to support read and write at scale. It has to be infinitely scalable. It has to support ACID transactions. It has to be highly performant, continuously available, easy to use as well as maintain, and it must come cheap. So obviously, as you know, if nobody can just tick all the boxes. So then what's the choice? Let's just explain the CAP theorem. CAP theorem talks about consistency, availability, and partition tolerance. So consistency means all clients see the same data at the same time. Whereas availability is the system continues to operate even in the presence of a node failure. Whereas partition tolerance is the system continues to operate in spite of network failures. So whenever data gets moved between different clusters, let's say there are three nodes in a cluster, and the network goes down, and one data is some data element is present on one node, and the other element is present on the other node. Then will the application function properly? If yes, then it is partition tolerant. Whereas if it's not, then obviously you need to design the application differently. So you have two choices here. Either when the communication between the network breaks and the partitions cannot be synced up with each other, then you take down the application, in which case you're sacrificing availability, but you're letting partition tolerance and consistency be the important ones. Or you allow different partitions to go out of sync because the network communication has broken, but the application will stay available, in which case you are going for eventual consistency, but you are focusing on availability and partition tolerance. The center, as you see over here, this particular area, this is a no-go zone because none of the databases class like certify on all these three different parameters. So they are either available and consistent, or consistent and partition tolerant, etc. And these databases have been grouped under what bucket they fall under. So for example, MongoDB is typically consistent as well as partition tolerant, whereas Cassandra is typically available as well as partition tolerant, and it is eventually consistent because if it is on this particular side, it goes to consistency after a certain point of time. But in most of these databases, you have a feature wherein you can turn off and on certain behavior, so these can be tuned. Now coming to AWS databases, you have relational databases, which is primarily Aurora or RDS, and it is also including Redshift. Plus there is a key value database also. In a key value database, typically you have got Amazon DynamoDB. So DynamoDB, when it is used mostly in high response requirements. For example, Amazon Prime Day sale, when you may have millions of requests per second, because it has got a global table feature also. So for example, you may have a service which is like an authentication service. It should be available globally. So in that case, that the latency should be minimal, no matter from what AZ you use it from. Then document DB. The document DB is useful typically for a JSON, wherein it has got flexible schema and it is compatible with MongoDB. And obviously, relational database, as we know, supports ACID transactions, but it doesn't allow you to scale horizontally that easily. So that's when you choose these two databases. So you might have heard that Amazon themselves were earlier using Oracle RDBMS, but when they found out that it did not allow them to scale during their high usage periods, they invented their own databases. So that's why we should also try to see which database we can fit for our use cases. Then it comes to elastic cache. So if you are having scenarios wherein you need microsecond latency, then elastic cache is the way to go. So one important metric is a 2 second delay increases the bounce rate in your websites by 100%. So and 25% of those people who just get bored of waiting never come back and they just go to your competitor. So whenever there is a high requirement of performance time, do consider caching options. And the main thing is these caches need not always be databases which are only memory resident. You can have a memory DB, Amazon memory DB, which has got durability. So it is in memory Redis compatible, but at the same time it stores data in transaction logs, and that gets replicated to at a time 5 different availability zones. Then what is a graph database? So graph database is Amazon Neptune. Typically it is used when you have certain dependencies like a recommendation. One thing depends on the other and you want to see the complete chain. So it could also be in like a fraud detection scenarios when the money is going from one entity to another and there is a big chain and you want to just track it all down. Then graph database is typically useful. Then for time series, you have got Amazon time stream. Then for ledger databases, you have got Amazon Quantum Ledger Database. And obviously for wide columns, you have Amazon Key Spaces. So a quick comparison between all these databases so that you can choose the right one. RDS is used for a structured data. So it can be used for simple OLAPs, but typically for a higher, better performance using OLAP, Redshift would be advisable. Now this Aurora RDS, they are all for structured, whereas Redshift can be for semi-structured also. As you know, Redshift has support for Spectrum, using which it can directly query data in the S3 data lake. And when it comes to the size keeps on growing when you go from RDS to Redshift. Redshift can go up to petabytes, and the others are in the lower terabytes to mid terabytes range for RDS. Then when it comes to performance is better when it comes to Aurora as compared to an RDS. When it comes to Redshift, it has got a medium performance because the data volume is higher. And when it comes to operational overhead, since you have to it's not serverless as such, so the operational overhead is moderate. Whereas when it comes to Aurora, there are two tiers. There is a provision tier wherein you fix your capacity, and there is a serverless tier also available where you decide what should be the maximum and minimum range, and within that range Amazon will themselves take care to allocate capacity. So that's where the operational overhead will be relatively lesser. So that's why it is considered as on the lower side. And then it comes to DynamoDB. It has got semi-structured type of data, and it is a key value, whereas in Neptune it is a graph data sets. And again, if you see, operational overhead is very low over here because these all come as serverless. And then if you see again the size, it is a high TB range for all these databases, so they can typically handle a large amount of data. Whereas since elastic cache, it is memory based, so it has got a relatively lower TB range. So essentially you have to architect your solution so that you can take the best advantage of all the things that these databases have to offer.